So I hope that you can see my screen, right? Boleh nampak screen saya?
Boleh sir.
Boleh sir, boleh.
Okay, thank you. Dennis, right? Take, right? Good. So for today we will learn the other system. Okay, what we're going to learn. So we have learned translation system, rotational system. For today we will learn about 3 more system. Okay, so I hope that I can finish for less than 1 hour lah. Okay. For those who can't to slide in for the attendance, so we will do it later lah. Okay. Alright. Let's look at gear system. Okay. Everybody, are you ready? Right? You ready for the class? Okay.
Yes.
Yes.
Yes, ada.
Wow, 60 student. Wow, ini ada who is there? Ini mesti ada pendatang asing ni. Okay. Alright. Gear system, that's mean that system is involved in gear lah, of course. Okay, so let's say you have 2 gear here, R1 and R2, 2 gear with the radius R1 and the second one is R2. So of course when you will have some angular displacement theta 1 and theta 2. Okay, let me draw it for you. Okay. Sorry guys, I cannot find the full version of MCAP. So some of your friends suggest I can use what is it, cam and so on, but that one cannot change this size. So I try to find another tools that can help. Okay, so for gear, alright. So what you will learn for today, so let's look for the gear one. So you have let's say this one, the big gear, okay, then this one, then you got it is small gear here. Okay, let's say I draw it as far away. Okay. Is okay, alright. Okay, so this one have the radius R1 and this one have the radius R2. Okay, so and then you have the input. As I mentioned you before, look at the input first. This one, the angular displacement theta 1. Okay, this the input is theta 1 or theta I. Okay, so this one theta 1. So that's mean you will have the angular displacement for gear 2 and theta 2. So your gear needs to rotate. One is the anti-clockwise and another one is clockwise, right? So it need to be what we call it opposite, right, to each other so that your gear can rotate. Okay, right? And the other one, you have the gear that rotate clockwise for gear 1 and the other gear it rotate is anti-clockwise. Okay, so you cannot have the gear that rotate the same direction, right? Because if that, it will stuck to each other lah. Okay, you can sekat. So from this one, you will got it equation, the relationship between these 2 gear in term of gear ratio, and so you will have a radius R1 over R2. This is the first equation. So like I mentioned you before, we want to find the equation from this system, right? So if you have another system, you can find it. So and then you also have the T ratio, right? So the T ratio and T ratio. So I don't know why you use the same symbol. Okay, it is the symbol. All right, and then you can get another equation between the angular displacement here and also radius here. Okay, so if you look at this one, So when your gear rotate at a certain angle, it will give you the same angle. For example, this one angle, right? Same angle. Okay. Theta. I hope that you can see. Boleh nampak? Boleh? Boleh ke? Nampak? You
Baru
need
tu
to
nampak.
zoom out. You need to zoom out your eyes. Use your what we call it, your power of your eyes lah. Okay. So what's the relationship between radius and also the angular displacement? So it will give you some talk about it, right? So R1 theta 1 is equal to R2 theta 2. Okay. So this is the third equation that you will have. R1 theta 1 is equal to R2 theta 2. Okay, done. All right. And then from the angular displacement, you also can differentiate it, right? So R1, you differentiate the theta over time, then you can get it to theta 2. So this one, it will give you the angular velocity, right? So R2 omega 2. Okay. So the next equation for this gear, it give you R1 omega 1 R2 omega 2. Okay, so this is the relationship between radius and also theta. So first, your relationship between gear ratio and gear teeth, right, and so on. All right, and as we know that when we have the radius and also the angular displacement, we can get some torque over here, right? Because the angular displacement and also the radius will give you some torque. Okay, so this one is R1 and this one is R2. Okay, right. So next is the relationship between torque and also what we call it, force. Okay, so right now you have gear 1 right here. Gear 1 we rotate as anti-clockwise. Okay, anti-clockwise. So what happened is R1 we apply some forces to what we call it second gear here. So you will have some force which is F1. Okay, you can look at the notes that I give it to you. F1 here. All right, and so when this one apply force to the gear 1 we apply force at this second gear, right, F1, and the gear 2 try to force it back, right, try to fight it back. So now you will have the force F2 here. Okay. Is it clear this one? Gear 1 apply force F1 here, right, and this one we apply force 1 at opposite one. So because you will have the F1 plus F2, we can say that F1 minus F2 equal to 0. So F1 equal to F2 here. Okay. And then another one is when you have the F1, right? It's also will like this one lah. Okay. Gear 1 it also have F1 here, and F1 here apply to gear 2 F1 here. So this one will give you the torque. We call it torque tau 1. Okay, another one it will give you torque tau 2. So torque T1 tau 1 is equal to R1 time with F1, and you got it is T2 R2 time with F2. So T1 over R1 you got it F1, T2 over R2 you got it F2. Because the F1 equal to F2, so you can now have another equation T1 over R1 equal to T2 over R2. So I use the word T, okay? Right. So this is the second the equation number 5 that you need to remember. So you can have a T1 R1 equal to T2 over R2. Okay. Right. So far, you have any question about this one? Ada apa-apa soalan?
Tak ada sir, tak ada.
Ada Clear Gear 1 will give some forces F1 here at the gear 2. And it also have the same forces F1 here, right? So that this gear can rotate anti-clockwise. Okay. So when F1 rotate here and then theta 1 rotate here, you will have the torque T1 here. Okay. But this one you will have torque. That means the direction will be like this one opposite lah, right? Kalau tak opposite, it will stuck lah, right? Okay, so you have here. Now you have the fifth equation. Okay. Right. The same thing if the angular displacement at the opposite direction, it means that we clockwise, and then you will have force that going down here, and this force will apply to another gear here, and then the torque here, and then you will get the same equation like this one. Okay. All right. So let's look example. Okay. Wow, 62 student. Wow. Right. Okay. Example 2.1. Okay. 2.1. No question? Alright. So let's me look at this one. Yes, sir. Nopi nak tengok whiteboard jap, sir. Okay. Dah tengok whiteboard. Okay, nampak whiteboard This is whiteboard Okay. Example 2.1. Alright. Wah, bagus. Baguslah pelajar ni. Alright. Produce the block diagram. Okay, for the rotational system shown below, considering torque TA. Okay, TA, this one is rotate clockwise if you look at from the right. Okay, at the input variable and angular displacement theta at the output variable. Okay, so first thing that we need to know is the input TA, right? I call it TA, torque A, okay? And the output will be angular displacement theta, okay? So first of all, you need to draw the free body diagram of the gear itself, okay? So let's we look about it, right? So maybe I need to draw it, right? Okay. Give me some time to draw. Okay. How to draw it? You have some gear here. Then you have some gear here. I hope that you can accept it. Okay. Boleh Okay. Alright. Now you have some rigid body here. Then you also have some damper here. This one is give you the J, this one the beta, and also you have the angular displacement theta, and this one the shaft K, dan this one give you R1, this one give you R2, and you will have the TA here. Okay, so first you need to draw the free body diagram, but you need to look at the gear first. Okay, look at the gear. So now you will have the small gear, okay, and then you will have the biggest gear. Right. Okay. So this gear, let's say I draw like this one. This is R1. Okay, R1. So this one R1, and second one is R2. Okay, now you have the top is moved to here. This is T8. All right. Okay. All right. So let's solve for the gear first. So the information that you have is TA, R1, this one, and R2. Okay. So what can we got it from here is when you have a TA here, that's mean you will have some forces, right, that react to this gear FA. Okay. And then this also force the same force that we apply to this gear, right? This one. So that's mean you will have some torque here, right? Like I move it T2. Okay. Why the torque move at this direction? Right? Because this gear, the first gear, the input will be like from this gear first. It will rotate clockwise, and of course this gear will rotate anti-clockwise, right? So remember that the torque need to be opposite direction. One is clockwise, and the one is anti-clockwise. Okay, is it clear? Clear? Yeah. You clear or not?
Clear, Doctor. Clear. Clear, clear, clear.
Thank you. Thank you. All right. So now, what the relationship between this one is you have a TA. So now you have the R1 FA. Yeah. And then you got it. Another question is T2 R2 FA. Okay. Right. It's the same thing lah. FA and also the F2 is the same thing. Right? Remember? Okay. So from this one we can write equation that is from T2 over R2 is equal to TA over R1. Okay, right? So this is the first equation that we got it from the gear. Okay, done. All right. So number two, you need to solve the initial body right here. So, free body diagram. Yeah, and the initial body will be like this one. Okay, and we have J here. So look at the torque that apply from the gear to this initial body. This means that T2 here we apply to this one, right? Okay, that's mean going down. Okay, right? Okay, so this means T2 we apply to here. This one is T2. Okay, so when this T2 we going down, right? We rotate it. So that means you will have another forces which is FD, right? Sorry, TF, okay, right? Top from the friction B, okay, done. So you rotate this one, that means you will have top here, TF, okay, alright. So when this one move is that means it rotate like this one, your the shaft. So your shaft, that's mean, okay, this is initial body. It should rotate this one. So that's mean your shaft will fight back. Okay, it goes direction. Okay, this body move this one, shaft will fight back. So that's mean you will have TS T shaft. Okay, remember T shaft, TF, and T2 is from the gear. Okay, is it clear? This one? Any question that you want to ask? Clear or not? T2 is from the gear, from
No,
this
sir.
one.
No, sir.
Okay, from this one
No,
T2.
sir.
Okay, good. So this one is T2. right? And then after this torque apply, then you will have the torque from the friction, right? It will fight back, okay, going up. And also the torque is applied here, so this one is shaft wheel TS. Yeah. Okay, done. Now you will have the summation of torque equal to J alpha, and then going down is positive. Okay. Why I choose this one? Because I look at the torque that apply to the initial body. So this one will be the input. Okay. So that means you will have the T2 minus with TF minus with TS equal to JD squared. Okay. So this one, the top angular displacement is theta, JD squared theta. Okay. So this is the second equation. Okay. Done. And then the other one is the another component lah. So look at the gear done. So you look at the friction. So you have the TF, BD, what is it? BD theta. Okay, done. And then you will have the shaft TS. So this one is only one is free and one is rigid. So you will have what? K theta. Done. Okay. So TF and TS friction and also shaft. Right. So let's look. Question number one for gear. Equation number two is from the initial body. And equation number three is from the friction. So this one, number three. And equation number four is from the shaft. So you got it 1, 2, 3, 4. Okay. All right. Oh, yeah. Okay. You can look at my notes again lah. Alright. So this one, the F2 is equal to actually the FA lah, because the Newton third law. Okay. Any question? No? This is about, okay. All clear. Okay. Good. Good, good, good. I'm glad to hear that. Okay. For the flea body diagram, for the flea, for the block diagram, sorry, for the plot diagram, so you need to draw by your own lah. Okay, I hope that you understand how to draw it. Is quite simple. Maybe I can show a little bit lah. Okay. So from the block diagram, okay. So your input now is TA. Okay, this is your TA, your input. Then we try to solve the equation number one. R2 over R1, then you got it is T2. Okay. Alright. So we can start from the equation number one, from the input T2, and then you can solve the equation number two, T2 minus TF. So you can have the comparator here. Okay, T2 minus, so that's mean this one will be minus, this one is plus lah. So T2 minus TF here, and T2 minus TS. Okay, and then you got it, this one. Then you can time with 1 over JD squared. Then you can get theta. Okay. So this one, you will multiply with 1 over JD squared. Then you can get a theta. And then after that, you can solve for the equation 3 and 4 here. Okay. So that's why you will got it, the block diagram like this one. Okay, so that's it for chapter here. Okay, don't have any questions, so we proceed to another one. Boleh Tak ada masalah Okay,
Boleh.
boleh. Okay, right. Okay. So, before we go to the level system, so let's go first to the liquid level system, because this one is very easiest one. Okay, alright. Alright. Another system that we have right now is a liquid level system. So on this one, you need to play around with four variable, which is level, flow rate, fluid resistance, we call it R, and fluid capacitance. Fluid capacitor, we call it C, C. Okay, C, CP. Okay. Resistant is you will have some valve here, right? Okay. So when you open this valve, so you can see the height, right? The height from the input we go to the output right here. Okay. So in this case, you will have some equation. Okay. Saya ni suka lukis sikit Okay, so I like to draw so that you can fully understand. So for this question that you need to remember is the fluid resistance. I call it R, right? Okay. So this one R, and then you will have the height for this one is H1, and then when you open your valve, then you will have this one, the H2. Okay. And then you want to look at the flow rate at this valve, or we call it the resistance here, right? Call it R. You want to look at Q. See, the flow rate is Q. So the equation that you will have now is Q is equal to 1 over R. 1 over R, you need to multiply with H1 minus H2. Okay, H1 minus H2. Okay, so this is the first equation. Q is equal to 1R, H1 minus H2. Okay, so this is the first equation. Right. So the block diagram, you can see that. Okay, and then another one, you have the capacitance, right? Capacitance. So capacitance, that means it will be like this one. So you will have at a certain H here, okay, and then this will be your capacitance C, the capacity of the water. So this one is the QI, and then the result will be Q naught. Right. So the equation will be input minus with the output. QI minus Q naught is equal to C dH over dt. Right. So your capacity of your water is depending on the time, all right? This one. So now you can have the Q naught over QI over Q naught is C D H. Okay, D, that's mean D over dt, right? So this is the second equation. QI minus Q naught C D H. Okay, right. Then of course lah, if you want to find the output H, so you can rearrange the equation. So in the liquid level system, is only two equation, right? One is the resistance, and then one is capacitance. Okay, right. So that's it for liquid level system. Okay, so let's look. Yeah, we have one or two example. Okay, let's look example 2.1 here. Okay, Consider the liquid level system shown below. Okay. So the variable to be monitored are the head, H, right? Head or height. And the flow rate Qi and the output is Q naught. The system parameter are the fluid resistance R, say you have the resistance R, and capacitance C. Produce the block diagram considering flow rate Qi the input and the level H the output. Okay, first you need to um, identify which one the capacitance, which one the resistance first. Okay, so I will draw it again. So then, okay, this one is R, and this one you will have some height here. We call it H only, and then you will have some input Qi, and then capacitance here, and then the output is Q naught. Okay. So first of all, you need to look at the input, right? So in this case, the input is Qi and the output is H. Okay, that means when the flow rate, right? The input is flow rate, and then you want to monitor the height of this capacitor by adjusting the R. Okay, so first look at the input first. So the input is Qi. So if we go to the capacitance first, right? So the block diagram of the system will be like this. Okay. And you have C here. Then you have the Qi. And then this one you have the H. And this one you have the Q naught. Okay. First, look at this one first. Okay. Capacitance. So of course you will use the equation number 2. Okay. So Qi minus Q naught is equal to CDH. That's it. This is the equation number 1. Okay. So far so good? Boleh? Faham eh?
Faham.
Okay. Good. So number 2, now after you go to the capacitance, it will go to the resistance here. Then you need to draw it again. For this system, I advise you to draw it. Okay. Then you will have, now you will have the R here, and then you will have the Q naught here, right? And then you will have the H here, right? This one H, okay? H, and then of course you will have the H naught is equal to 0 lah, because remember, so in order to find the resistance, so you need to have the H1 minus H2, right? So right now you have H minus H naught. H naught equal to 0 lah. Okay, there is no height there. Okay, so this one, so that's mean the equation number 1 is Q naught is equal to 1 over R. So H minus H naught. So because the H naught is 0, so this one, so Q naught over H. Okay, so this one, the second equation. Okay, then you can draw the block diagram. So if you can see that this one Qi, number 3, so you have the Qi, right? The input and the output is H. Okay, Qi the input. Alright. So let's solve it. Which equation that are you going to use? So you can try from the output or the input, it depends. So let's try for the input. So equation number 1, Qi minus Q naught. So that means you will have some comparator Qi. This one is Q naught, and This one is plus, this one minus. Done. Then it will multiply with 1 over CD. 1 over CD. And then you will got it H. So done. Question number 1 done. Okay. Then let's solve for the question number 2. That's mean question number 2 is from the H. We can multiply 1 over R from the H. Right? Take the H, can multiply with 1 over R, and then we can get back the Q naught here. Then solve equation number 2. Okay? Boleh nampak whiteboard?
Boleh.
Okay. Good. So for the liquid system is only 2 equation that you need to remember. One is the resistance and one is the capacitance. But you need to look at the input first. So the input will go to the resistance first. So you need to draw the resistance. Resistance that means you will have the QI, the input flow rate and the output flow rate. Alright, and then you will have some height there. Okay. So let me see if there's any question. No. Okay. So let's look example 2. Yeah, the example. Okay. Alright. Example 2.2. So we can go through this solution here. Okay, further the block diagram for the liquid level system shown below. If the inflow rate QI is taken at the input and the head or level H2, okay, this one the H2 as the output variable. Okay, so right now you will have the input going to the capacitance first, all right, and then after that we go to the resistance, done, and then after that we go to the capacitance, done, and then after that we go to the resistance number 2. Okay, done. Okay, so the solution is here. So you need to draw the capacitance first. Okay, QI, capacitance, and Q naught, right? And the height will be H1 here. And then you will got it is QI minus Q naught equal to CDH. So which is C1, D, and H1. Done. You got it equation number 1. And then after that, you will go to the resistance R1. So you draw again. So this is the height number 1 here. Height number 1 here. Okay. And then if we go to the height number 2 here, the output is height number 2 here. Okay, height number 2 here. H1, height number 2 here. It will produce height number 2. So, and flow rate through the resistance R1 is Q naught. And then you can get it that Q naught is 1 over R1 times with H1 minus H2. Okay, done. You already got equation number 2. And then from this one, if we go to capacitance C2. So the input to the capacitance C2 is actually the Q naught, right? If we go to capacitance number 2. So that's mean Q naught, capacitance C2, and the output is Q, right? Is Q, okay? Right? Okay. So the equation will be, remember, input minus output, okay, Q naught minus Q, and then CDH with C2, D, and H2 here, done. And then after that, the last one, if we go to resistor number 2, the input, sorry, you have the height H2 and height H3 maybe, is equal to 0 here. Okay, so or H naught equal to 0. So the resistance for R2, the flow rate that going to the R2 is the Q, and then you will have Q equal to 1 over R2, H2 minus H naught, which is the H naught equal to 0, and then you will have only 1 over R2, H2. Okay, and then this is the all equation for this one, and then you can draw the block diagram from based on the equation. So you can start from the input or you can start from the output itself. So let's start from the input, Qi minus Q naught, and then equal to time with 1 over C1D, C1D, and then you will got it the H1. Okay, done. Then you can solve as equation number 2, H1 minus H2. Okay, H1 minus H2, you time with 1 over R1. Okay, 1 over R1, then you can get it Q naught. Alright, done. Then Q naught minus Q. You can solve equation number 3, Q naught minus Q. Then you will time with 1 over C D2. You can get the H2. Done. And then you can solve for the Q, 1 over R2. Alright. For the H2, you can take from this one. Okay. For the Q naught, you also can take this point. Okay. Alright. Okay, complete solution for the liquid level system. So far, do you have any question? Do you have any questions so far? Huh?
No, sir.
Oh, is it clear? Two system right now we have learned the gear and also the liquid level system. Okay, all right. Okay, the last one. Let's go another one. The last system. Okay, level system. Okay, right. I hope that I got enough time lah. Okay. Yeah, a little bit. Okay, good. Okay, levels and gear, mechanical device used to transfer energy, blah 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 blah. Okay, so we have know that for the level system we have the class 1, right? For example, scissor, macam gunting kan, right? So you have the fulcrum here, and then you have some load, right? For example, and then this is your effort. Okay. And then the class 2 you have the wheelbarrow, right? Kereta sorong to the that's mean the fulcrum as the wheel. Then you have the fishing rod, blah 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 lah. This one. Okay. So for the fixed level system, there are certain parameter that you need to look at is okay. For example, like this one, the fixed level system, you have the mass here, alright, and then the mass will produce the force F2, for example, load force, right? So then you need some effort, right, to what we call it, to pull the mass go up, right? So in order to draw the force at the level system, so you will have the level system here, okay, this one. You can draw the free body diagram here, and then you F1 here, apply to F1 here, and F2 right here, and then you can get it some torque. F1 you time with L1 here, and then F2 you will apply the L2 here. This one is basic lah, torque, right? Okay, F1 you go F2, and also by looking at the displacement, this one, okay. This one, when you have the level system here, right? So your level system will, for example, give you some angle here, this one. So you will have some angle here and the same angle, right? For example, theta. And from this angle, you can find the sine theta, right? This is Z over L1, right? This will give you some displacement, Z and also Y, for example. Okay. And then the same angle for this one, sine theta is equal to Y over L2. Okay. So this is the basic one lah, right? And then you can find the relationship between Z and Y. Okay, sine theta equal this one. Then from this one, you can find some ratio. Okay. Right. All right. And how about the what we call it working level system, right? Some displacement, right? Will be here. So this is the fulcrum here. So you got it L2 and L1 here, right? L1 is from Z going to X, and then you got it A and B here. So L2 equal to B plus A here. And then what happened when you got it some displacement Z here, and then Y here, okay? Then from this one, you also can have the sine theta is equal to Z is over to which one? L1 plus A. Okay, L1 you plus A, right? Z here, so Z is equal to L1 you plus with A. Okay, done. And then you also can have the sine theta X over A, right? Done. And also you can have the sine theta Y over B. Okay, and done. Right. So the relationship between all these three parameter is going like this one lah. Okay, this one is simple lah. When you have the level system, so you will play around with the sine theta. Okay, you want to find the between the displacement and over the length. Okay, right. So let's go through this example. Okay. Right. Example 2.1. Right. So now you have some level system here. Okay. Then from this one, you got a spring here. Okay. Then the other one, you also got a sun spring here. This one is XI, and this one is XA. And you have some vacuum here. And then this one is A. Another one is B here. And this one you have the SP, K1, this one K2, this one is S0. Okay. Alright. So there are three parameters that you need to look at. Is one is the force, okay, right? One is the force that apply to this level, and then another one is looking at the displacement, right? And then number two, you need to draw the free body diagram for the mass, okay? Right. This is three parameter that you need to look at. Okay, first of all, so need to look at the force at the level lah. Okay. Right. So draw this again. Boleh kalau you have any question, you can stop me and ask. Okay. Right. So we want to look at the force that apply. Okay. In this example, the input now is the Xi, and then the output is S0. Okay. So you need to look at the input first. That's mean your SI, right? You force it on the right, right? Force it in right. That's mean going there is positive. Okay. This is our all right. Okay. So that's mean when you pull this spring here, so you will give the force, right, at this one. So this one you will give some force which is Fs2. So you will got it for from this one if fs2. Okay, clear? So at this point, right, when this level, right, it pull this way, okay, that's mean this lever try to push this spring, right? This lever try to push this spring, pull this spring. So the force from this spring will fight back, will push it back. That's mean you will got it the force from here if Fs1. Boleh? So this one, the force from the spring, we try to fight back Fs1. Boleh tak? Clear tak? Is it clear? Senap saja ni? Ataupun dah left? Is it clear?
Clear.
Okay. So when you pull it, so that's mean from the spring, right? We pull, right? And then this one, the force will go into this direction. Why? Because this spring we try to push it back, right? Okay, done. So from this force, so we can get it if Fs2 you time with A, Fs1 you time with B. So this is the first equation. Okay. Then number 2, you need to look at the displacement, right? The displacement going to the level. So now you have the XA here and you have the XB here. Okay, and so this one will give you sum theta and also the sum theta here. Okay, now you can get it is sine theta. This is the A, right? Okay, this is the B. So this one is SA and also this one is SB. So sine theta is equal to SA over A, done. And you also can get is sine theta for this one is equal to SB over B. Then you can get it SA over A here equal to SB over B here. So this is the second equation, 1 and 2. And then the last one, for the free body diagram for the mass. So this is your mass M, and M have the displacement that you have is x naught, and then only one point that's react to the mass. So this one. So because of the force S1 going there, right? So at this point going to the right direction, that means another direction will go to Fs1 here. Can you get it? Right? Force going to this point at the right direction and another one will be at the left direction. So that's why you can got it if SF1 here. Alright? And then the summation of force equal to MA. Then you can get it if Fs1 equal to what we call it md squared x no. Okay, so this is question number 3. Okay, alright, alright. Okay, then the next question is the components. Number 3 is the number 4 is the components. Okay, so right now you have the spring here. All boss is free. All boss is free. That means you can get it Fs2 equal to K2. Sorry guys, susah pula nak tulis. K2 XA minus XI. Okay. Oh, sorry. SI minus XA. XI minus SA. Why? Because I take it the input first, you minus with the output. And then you also have the spring FS1 because post is also free, alright? So you can get it K1 XB minus X naught. Okay, why? Because the input is to the spring is XB, the displacement is to the spring is XB minus with the X naught. Okay, then you can got it number 1, 2, 3, 4, and 5. So there are 5 equations from this one. From this one, 5 equation, you got it. Okay, 1 and number 2 and number 3, number 4 and number 5. Alright, so there are 5 questions that you can get it from the system, and then you can draw the block diagram here. SI and S naught, SI the input, and then the output S naught. Okay, so you can start from where? SI minus SA, equation number 4. SI minus SA, you can got this one. You time with K2, you can got it FS2. And then you multiply with, then you can solve the equation number 4. You multiply with the A over B, you can get it FS1, done. And then FS1, you can solve it for equation number 2. You multiply with 1 over MD squared, you can got it S naught. And then from that one, you can solve another equation. Okay, alright. Is it clear? This one, the level mass system. Boleh is combined between level system and the mass. Boleh tak? Clear? Alright. Macam mic was disconnect. Kenapa?
Tadi saya ada tanya soalan tapi dapat dah lepas awal-awal
Tak tanya soalan. Dah lepas. Mana? Tak ada pun. No question.
Saya ingat doktor tak dengar macam tak apa-apa. Tak apa, it's okay.
Tak dengar lah dia. Tak apa, boleh ni boleh PM tepi. Okay. Alright. Is it clear? I hope that you can go through all my notes that is already have the solution for you all. Okay. Alright. Good. So if you don't have any question, so sorry guys. So I take 1 extra minutes. Okay. So that's it for our class. So I will see you again. Anak tengok whiteboard sir. Anak dah kahwin Hakim Rafi'i. Nak, okay. Okay, ni whiteboard Hakim nampak. Alright, for this one, why I just put it is plus, right? Because the input that go to the this mass actually is the XB, right? The XB, okay? Go to this mass. So that means this XB will become the input. So for the first thing, sorry, I just assume that okay, going to this direction is positive, right? But for this spring, it's only react for this level. So at this mass, so we can take it the direction is positive. Okay. All right. Is it clear? Done?
Yes, Doctor.
Okay. All right. So that's it. So I will see you again on Thursday, inshallah. Okay. All right. So for another system, I'm not cover in this lecture. So if we have some time, I try to cover it. So next week we will learn about the block diagram manipulation. This one is quite interesting one. Okay. So I think thank you. Sir nak tengok block diagram. Fahmi Ashraf, you can look at my notes, right? Awak boleh tengok notes saya. You can get it from the e-learning. I already uploaded that. Okay. Alright, that's it. Thank you guys.